All right, so here we go. All right, so that's an absolute value graph, but which one of those is it? It's a tricky question. Process of elimination is a good idea on multiple choice. Let's do some of that. Could it be A? Maybe. Let's come back to A. Could it be B? Yeah, I know it is A, but it might be. We'll come back to it. Look, we can eliminate B. Why is it not absolute value? Why is it not B? Absolute value of x plus 2. Why is that wrong?
Influences the y.
Yeah, that's a y effector, huh? That would mean up to, wouldn't it? That would be up to, because whereas if the x is in there like that, that means, what does it mean when it's in there? That means left to, because x always does the opposite, huh? Plus is actually left, minus is actually right. And this one has been moved right to. So we're thinking it's probably like absolute value of x minus 2, aren't we? Which is a little confusing with the way they've turned around A. We'll talk about that in a minute. But it's got to be something like that, doesn't it? Because it's been moved right to. Right to. So it's not B for sure. Let's just go through process of elimination. It's not B, because that would be up to. Remember when the stuff is outside of x's little world, whatever x's world is. Absolute value, square root, power, 2 power, 3 power, whatever. Whatever little thing is happening to x. If numbers are outside of that, they're a y effector. They're up-down effect, aren't they? If it's in there, like C, it's absolute value of x plus 2, it's in there, then that's going to be a right-left effect. But that's the wrong one. Plus 2, no, it's supposed to be minus 2, so it's not C for sure. D, no way. What is D going to do with the minus 2 outside of the absolute value? Down 2. That's not what's been done to that graph. So it's not B, C, or D, right? We all good with that for sure? It's either A or E. Some of the ones on here, as you can see, are none of the above. So it could be none of the above. And A looks funny, doesn't it? Because isn't this what we would expect right here for right 2? And yet option A has turned it around. Is that okay? It turns out it is. Rather than me giving all the fancy algebra rules for why that's the same thing, you know what I would do? There's too many fancy algebras. I would make a quick little table and test it. Be quicker, easier, more reliable for you. I'll show you the algebra rule 2 in a second. But let me just, what I'm saying is I would just go, look, I don't know, is that the same as that? Because I know this is what I'm looking for, but maybe A is a tricky way to say the same thing. It is, it turns out. How can I know for sure? Well, look over at the graph. What are some nice, easy points you can tell around the graph? Like, what's this dot right here? Can you tell the coordinates of that dot? Isn't that over 2 up 0? So I'm just going to say, well, does that work? X, 2, Y, 0. Does that make A? Does A work with that? If X is 2 and Y is 0, is that true for A? Yeah. Yeah, but okay, that's a special point. How about another one? How about, like, what's this dot right here? That looks like 1, 1, doesn't it? Right, over 1, up 1. Does that work for A? Put in 1 for X, put in 1 for Y. Is that true for A? Yeah. 2 minus 1, absolute values, 1. Yeah. 1, 1 works for A. Well, okay, one more. How about this point right over here? This looks like over 3 up 1, doesn't it? That other dot? Over 3 up 1. Does that work for A? Put in 3 for X and 1 for Y. Does that work? 2 minus 3 is negative 1, absolute value. Positive 1, yeah. See how A is working for the dots that are obviously on that graph? So at that point, you have confidence to grab A. Now, algebraically, why are these guys the same? Because when you take two things and you switch the order of subtraction, all it does is change the sign. And absolute value doesn't care about signs. It makes everything positive in the end, right? Think about just numbers. This is what there's too many, if I was taking this test, I would probably just make the table. That's what I would do. But if I didn't think of the table thing, I would go, well, I don't know, can you switch the order of numbers? What's the difference between 3 minus 7 and 7 minus 3? Well, this is 4, and this is, it just changes the sign, right? When you switch the order of subtraction, it just changes the sign. So the only difference between 2 minus x and x minus 2 is a minus sign. And what does absolute value care about a minus sign? No difference. Makes it positive, right? That's why they're the same. Is that okay? So I encourage you, eliminate the obvious, the obviously wrong. And then if you're not sure, because some of these rules are tricky, we'll see again on like number 3 or 4. Super tricky. And I'm going to suggest make a table. Just find some dots. I should say find some dots that are obviously on the graph and see if they work for whatever option you're thinking might be the answer. That's good to have that skill too. Good? Questions on that one? So it is A. All right. All right, so number 2. So that looks like an x cubed graph, right? It's good to put the basic 6 on your 3x5 card. You get a 3x5 card, both sides, put anything you want, any notes on both sides of a 3x5 card. I would probably put the big 6. This is x cubed, the basic x cubed, before he's been moved or flipped or anything, right? That's the basic x cubed. Now, what does it look like they've done? Especially focus on where the center has gone. Where's the center of this graph? It's right there, isn't it? Don't look right there and go, well, it's at -3. No. That's just the tail part of it. Don't let that throw you off. Always focus on where the center has gone, because then you know what's happened to the entire graph. Right? They just grab the center and they move it. Where did they move the center to? Looks like left 1 up, is it 6? Yeah, and you can see there's a bunch of 1s and 6s down here. So yeah, certainly left 1 up 6. Okay, well, what makes an equation go left 1 and up 6? You know. You got to go +1, because remember, that'll mean left, because x does the opposite. And then what goes up 6 is +6 out there, because y does the normal. Left 1 up 6. So that's just A again, isn't it? That one's a little more straight ahead. We good there? On that, yeah. Yeah, I'm just looking at the center dot, and it looks like so it's all about the center. Focus on the center. You can tell right here is the center, because that's where it does its little twisty thing. It's where it bends, you know. It changes its concavity, is technically the word, and it looks like it's not centered on the midline anymore. It's a little off the line to the left. Good. Okay, I'll keep moving. Okay, so number 3, that's a square root graph. What have they done to it?
Flipped it and then move it over to the right.
So what have they done to that thing?
Reflected it and then moved it to the right.
Yeah, they flipped it sideways first off. You see that? This is a super tricky one. This one's super tricky. You're probably looking at the answer saying, it's not right, but it is actually right. It's D. We'll see why in a minute. But you might be looking at D going, that's the wrong kind of 5. Well, that's really tricky. Okay, so here's the normal square root of x, normally that way. Clearly it's been flipped left. It's headed left, isn't it? So they took it and they did it. Well, now what do you do to an equation to make it flip left? You put the negative right inside x's little world. To make it go down, you would put the negative in the front, huh? Everybody see that difference? So this is what we're talking about. So far, so good. And they've moved it also, and I'll get to that. But first off, it's got to be a negative on the x inside the root. Okay, well, just that, we can eliminate a bunch of options, can't we? Let's do that. Especially these graph ones are tricky, and you want to do some elimination. Anybody that does not have a negative right on the x is no way the right answer. Only way you're going to get this thing to flip left is put a negative on the x. So, no way B. B does not have a negative on the x. It put the negative in the front. That'd make it go down, as we said, so not B. C, he doesn't have a negative on the x either. Now, A has a negative on the x, and D has a negative on the x, and of course it could be E, none of the above. So B and C are out already. B and C are out. Now, what about, has it been moved up or down?
Down.
That's down to, what makes it go down to? Yeah, so it looks like D, maybe, no way A. Because what's that? That's a +2, isn't it? Don't be thrown off by that minus sign that comes after the 2. That's not his baby, right? This minus sign is on the root. You with me? You want to look at that as a 2 with an understood plus sign in front of him, option A, which is not the right answer, and a negative in front of that root. Think that way. If you're not already thinking that way, you got to start thinking that way as you move into calculus. Because we're going to move things around all the time, and when you move them, whatever sign's in front of them, that's their baby. That goes with them wherever they may go when you move things around. So it's not A. It's not A because he's got a +2. That'd be up 2. And he has a negative on the root. That'd move it down. That'd flip it down, and it's not flipped down. This thing's going up. So it's not A. So look, it's either D or E. It's either D or E. So far, so good. Now, it could be E. As you see, there are some none of the aboves on this test. But how do we know it's actually D? Well, D is written weird. It's written 5 minus x. I'm doing some of that. I'm doing it on purpose. I wanted to torture you. I wanted to get you ready for calculus. So you need to understand. You don't have to rearrange it. But if it bugs you, feel free. And I think it might help you, what would be legal rearrangement? It's the same as, yeah, minus x plus 5. Is everybody good with that? Do you all know that's the same? Why? Because what's in front of the x, minus what's in front of the x, didn't change. What's in front of the 5, nothing. What's in front of the 5 plus, same thing. Everybody see that? Again, you can move things around anytime you want as long as you take your baby with you, right? Whatever sign's in front, that's his baby. You don't leave your baby behind. Well, by the time I've had 5 babies. I don't know if I've mentioned that. Never thought I'd have 5 kids. But they're all old, getting older now. But my youngest one, well, by the time we had our 5th, I almost left without my baby. We were coming home from the hospital. Our routine, my wife and I, we'd come home. We'd say, let's go have a little lunch, just us two, face to face. You know, it'd be the last words I get with my wife alone before we go home and all the wildness of all the children. So it was our routine. We come home from the hospital with a new child. Let's go to lunch. Then we'll go all the way home. So we came home. Last one with Abigail, number 5. We came home. Came to the restaurant. Coming home from the hospital. Came to the restaurant. You know, and then we just jump out of the car, start walking in. Well, at least I was. My wife was not so stupid. She looked at me and gave me a smile and said, so do you think we should take Abby with us or just leave her in the car? You know, I'm like, oh yeah, Abigail. Well, you know, she's asleep back there. Anyway, so you don't leave your baby behind. You take your baby with you wherever you go. So those signs come with them when you move them. Okay, so what? So what? Okay, so it's this. Well, is that right then? The minus is on the x. That's good. That's what makes it flip to the left. Okay, great. The minus 2, yeah, that's down 2. But plus 5? Plus 5's not right. Yeah, it actually is. Well, plus 5, Mr. And you told us that's left 5. X is opposite. That's left 5, and this thing's right 5. That's not it. Well, remember the trick about the order in which you do a movement and a flip? So, long story, I'll show you the trick, but rather than, you know what I would do? What am I going to do? When I'm down to one option and I'm not sure. Table. Make a table or do some points on the graph and see if D's right. It's more tricky. These rules are tricky. But what can happen? Maybe I better show you because you're wondering. What do you mean it can? Remember, like it's all about the order. If you move first, then flip, the movement goes to the other side. If I was to take a graph and go left 5, which is what plus 5 would do, left 5, okay, and it's going like, well, I'm running out of room there. If I was to take a square root graph, let me come up here. Come on. Okay, if I was to come up here and take a square root graph and go left 5, so that would be square root of x plus 5. You with me so far? That's just left 5. Plus is opposite is left. And then, what? Flip it. Flip it so that it becomes minus x plus 5, which is really what it is, and that's the true answer. What would happen if you flip? Oh, I'm sorry, it's not supposed to be going this way. It naturally goes that way, doesn't it? I've just moved it so far. And then I flip it. Now, the trick with flipping doesn't just grab it where it sits and flip it like about that little point. No. You flip about an axis. You grab it here like a rotisserie. You grab the y-axis and you flip the whole y-axis. So what happens? This guy goes whoosh over to here. And the left movement becomes a right movement. Anyway, it's complex. Make a table. Plug in some points. You see, it can be tricky because whenever you have a flip and a movement on the same axis, things get tricky. So we have 2 things going on the x, clearly. We have a sideways flip and a sideways movement. That gets tricky about which one comes first or second and where it all ends up. So, long story short, make a table. Now, what do I mean a table? Or do some points is what I mean. Plug some points. So if you're thinking, I remember this, so what you should be thinking during the exam tomorrow is you should be thinking, okay, I remember these things are tricky. I know it's not A, B, and C. Maybe it's D. Let me write D up here, and I'm just going to do some points and see if they work. 5 minus x minus 2. It looks maybe right. Let's see. What's that point? So just grab some obvious points on the graph and see if they work. That's, what is that, over 5, down 2. There's a bunch of 5s and 2s and all this. It must be over 5, down 2. Does that work? 5, 2. Does that make the equation true? Does that make D true? Yeah? Negative. 2 equals 0. Oh, negative. Sorry, thanks. Yes, now yes. Negative 2 equals 0, root of 0, minus 2. Yeah. 5, negative 2 works. Okay, yeah, that's just one point. But how about one other one? Like, could I put in 6 and 7? They should be no. Well, can you put in 6 or 7? They're no, because that'd be negative in the root. So he's lining up well, isn't he? That'd be negative in the root. That's why it doesn't go there. It doesn't go 6 or 7 or 8. It doesn't go to the right. Okay. Can you put in like 4 though? 4 should work, and it should be some kind of dot. Looks like over 4 down 1 or something, maybe. Does that work? It looks like something like that. Put in 4 for x. Get the root of 1 minus 2. 1 minus 2. Yeah, negative 1. Yeah, that's it. See, it's D with the table. It's because the movement happened first, then the flip, so it ended up going the other way. So, all right, so that's pretty tough. Everybody seeing that? So plug in some points. Plug in some points and see if they work with D. D was the only option. If any one of them violated D or wasn't true for D, then we would have gone with none of the above. Right? We knew it wasn't A, B, or C. We good? So number 4, what does the negative do in the root? That one's easy, right? Just flips it left. No other stuff going on, so that's nice. Okay, so number 5. It's piecewise. It's in 2 pieces. Let's do process of elimination. Look at this piece here. One thing you can tell for sure on that piece is his slope. Yeah, maybe you can't figure out everything in the world, but you can figure out the slope. To go from here to here, you go up 4 and over 3, don't you? Up 4 over 3. So his slope is 4/3. You agree with me? For the left piece, his slope is 4/3. Nope for A. Nope for D. They have 3/4 instead of 4/3. It's up 4 over 3, isn't it? Rise over run. Good so far, so we've eliminated A and D. So it's either B, C, or none of the above. They both have 4/3. Now, is there any obvious problem you can see? B and C look very similar. What's the only difference between B and C? Right there. See that? What does that say? That say x goes only from 0 to 3. I mean, I don't care about the greater than, less than. And honestly, guys, I'm not going to try to trick you with stupid little stuff. Don't worry a lot about, oh, is it equals bar and it's an open dot equals. I'm not, let me just be straight up with you. I am not looking to trick you. I mean, students do way worse than I ever wish they did. I don't need to try to trick. I'm not going to put dumb little stuff like that. It's like brackets, parentheses, I'm just not going to play games with that. I'm going to be going after the main concept. So don't worry. Don't go, wait, is it equals that? So don't even look. I'm not trying to trick you. I'm not trying to trick you at all. I'm just trying to be straight ahead. So I'm not going to do some weird little thing. So don't worry about it. Don't even look close at that. Whatever. That part I'm not going to mess with you on. Just the main concept. What does this say? X goes from 0 to 3. I don't care. 0 to whatever. 0 to 3. Is that true? Does this right piece only go from 0 to 3? No way. That's just obviously wrong. Right? It goes well beyond 3. It goes beyond 5. Well, I put a root, right? So it's not C. So it's either B or it's none of the above. Now, if you have time, you gotta weigh out your time. We'll take tomorrow. We'll take part 1 for 25 minutes. I gotta lecture on new stuff for half the time. Sorry, I gotta use our time, and then all of Thursday. So the way the exam will. Is that right? Yeah, tomorrow's Wednesday, then Thursday. Yeah. So tomorrow I'll come to class, I'll lecture on some new stuff, which I'm sure you'd rather I didn't do, but I'm sorry. I got to keep the bus moving. So I'll lecture on new stuff for 25 minutes, then I'll go, all right, let's do part 1. This part 1, which is what, 8 questions or something? 8 questions. You'll have 25 minutes. You have much more time than you had. You have 25 minutes just for part 1 for these 8 questions. And then Thursday you'll have the whole 50 minutes for part 2, which is whatever it is, 16 questions? Whatever's part 2. They'll be the same as they are in this thing, part 1, part 2. Same type of questions, same number of questions, all that's the same. So tomorrow's no graphing calculator. Bring a scientific. Scientific would be fine, but no graphing because they're all graphs, right? So no graphing calculator tomorrow. Second half, 25 minutes for 8 questions. So I only gave you 50 minutes for the whole thing when we did it the other day. You'll have more time. All right, so anyway, so is it B or is it E? Well, it is B. If you have more time to work out the details, you can see it. It's all good. This is 4/3 x plus 4, and it's all right. I don't got time. Office hours, I'd be glad to go over more detail with you. It's all right. B is correct. Everything's good there. It's B. Questions on that one? Good? Okay, so we have 6 less than or equal to 2/3 x plus 4 less than 12. So what do we do with that thing? What do we do with fractions?
Get rid of fractions.
Get rid of them, huh? How do we get rid of them? Multiply by that denominator, that 3, huh? And everybody. Multiply everybody. So, and then here it cancels, so 18.
It doesn't matter if you subtract 4 first, right?
Nah, yeah, you could subtract the 4 first if you want. Doesn't matter. Now it's all about getting x alone. Now that I got rid of the fractions, that's always the first step. So I am going to be throwing fractions on there. Very next one's fractions as well. So I'm trying to get you ready for calculus. That is my job. And you got to be comfortable to have any chance to pass calculus. Fractions can't be a hard thing for you. You got to be very comfortable with them. They're everywhere in calculus. So get rid of them, right? Get rid of them. Multiply through. Get rid of them. And now x is saying, I want to be alone. I want to be alone. Okay. Subtract 12. Like that. We get, what's that? 6, 2x, 24. Last step, divide everybody by 2. 3x, 12, 3 to 12. There it is. Don't, like I said, don't even look. Princey bracket. I'm not going to mess with you on that. It's right. Bracket on the left, Princey. But don't even worry. I'm not going to mess with you on that kind of stuff. That seems very picky and stupid to me. Just the main idea. Did you get the 3 and the 12? Is that good?
Yes.
On that? All right, I'll keep moving. I know. So 4x plus 5 over 7 plus 2/7 minus 7x over 3. All right, so what do we do when we got like a couple different denominators like that?
Find the least common.
LCD, yeah. And do you realize when you do the LCD, you don't have to use both 7s, just 1 7 and 1 3. 3 times 7, 21. Do you remember that from your algebra days? So the LCD is just going to be 21 because it's 3 times 7. Don't need both 7s. Don't need to repeat things. So what do? Same thing you always do. You multiply through by the common denominator. 21, 21, 21, 21. Every fraction gets 1. And then what do we do from here? Now we cross cancel and multiply what's left over. So 7 goes into 21 3 times. The 7 and the 21 are gone. And the 3 is left. Let the 3 go boom and boom. Get 12x plus 15. Good so far. And then 7 into 21 3 times. 3 times 2 is 6. And 3 into 21 7 times. And the leftovers multiply minus 49x. So we cross cancel and multiply what's left over. You all good there? Got rid of the fractions. So now we have x's. Always do the x's first. X's on opposite sides. So that just means got to get rid of one of them, right? I'll get rid of the 12x. Just you could do the 49, whatever. It doesn't matter. What's this? These guys make 21. This is minus 59, 61x. Last step to get x alone, divide by the minus 61. Is it there? No, it's not. It's a none of the above. That's disturbing, huh? Sorry, I'm not meaning to disturb you, but I do have to put some none of the aboves in there so I know you're not just guessing your way through this thing, but that you're really solving problems. Sorry.
I got stuck on that one, so I got to
Got
that,
this, and you're
I
like,
go,
oh, I must have
wait,
messed
did I
up.
subtract something
Yeah.
right?
Yeah, if you get that, just move on. You know, the best, you do want to manage your time well on a math test, so just move on. If you get that, just circle none of the above, make a little mark in your paper, you know, because you'll be able to write on your test, you know, just like you wrote on this test. Just circle it, say, if I have time, I'll come back, you know, but just keep on moving, and then come back if you have time to check it. It's a little disturbing, but it's true. It's the right answer. Okay, so 4x squared is 10 minus 3x. How do we solve x squared equations? Do you remember?
0 on one side.
Good, yeah. First step is getting a 0, huh? Second step is you can try to factor, which means like the parentheses. Or what else you can do? You can do the quad, negative b plus or minus the square root of b squared minus 4ac all over 2a. That whole thing. A lot of people like that better because factoring can be challenging. So start by jumping these guys over to get a 0. So 4x squared, they change signs, as you know, like that. At this point, you can factor it. Like I said, if you're good and comfortable with factoring, then that will be quicker. But if you're not all that comfortable, just go ahead and do the quad. So I'll do both. Maybe, yeah. I'll just factor. So if you want to factor, you would come in, you'd go, okay. Basically, you're just guessing around at what works. Now, I write for front times front. What times what is 4x squared? Well, 2x, but it could also be 4x and regular x, couldn't it? Yeah, they both work. How do you know which one? You just got to guess around. So it could be 2x, or it could be 4x regulars. It's usually, not always, not in this case, the numbers closer together. Normally, it would be 2x. Turns out they won't work here. How do I know? Well, go on to the last. What is last? That means last times last to make 10. Don't worry about the negative. We'll do the signs later. What times what's 10? Well, 5 and 2. Or 10 and 1. So how about 2 and 5? Is that okay? Or 5 and 2, whatever? No, absolutely not okay. Right now, I don't even need to check anything else. No way, Jose, because 2 2's in the same parenthesis. You're never going to have two numbers in the same parenthesis that have anything in common, let alone are the very same number. You can't have a 2 and a 6, or 2 and a 10, or 2 and a 2, for sure, no. Why? Because, like 2x plus 2, you could factor out a 2. Well, so what? Why is that the end of the world? Well, there was no 2 factorable in the beginning. How could there be one later? Right? If there's nothing that comes out earlier on, we get in the, there can't be something common later. So no way is it going to be, I don't even need to check further. Well, okay, how about if you switch over to put the 5 here and the 2 there? Well, then they get the problem over here. No way with the 2 and the 5, right? Well, okay, go to the 10 and the 1. 10 and the 1, no way. 2 and 10, 2 in common, they can't be together. So do you see, I know for sure it's not 2x, because there's no way to make the 10 work. The 2, 5 or the 10, 1 can't go with 2x, so it must be 4x regular x. Okay, now let's go back to the 10. How do you make 10? 10 and 1 or 2 and 5. Well, if it is probably 2 and 5, try 2 and 5 first. It's usually the numbers closer. Can I put the 2 there? No, same problem. Can't have something in common. So the 5 would go here and the 2 there. That's the only viable thing so far. And that turns out to be it. Now, how do you know it's really it? You've got to check the oi, which is the
Oi.
what does the oi got to come from? The 2 inner, the 2 outer. That's what I and O stand for. Inner, outer. So the 2 inner make 5x. The 2 outer, 4x times 2, 8x. Can they make the middle, which is what? Plus 3x, right? The oi is to make the middle. Plus, yeah, they can. Plus 8. Now put the signs on. Now, first time I put the signs on. Plus 8 minus 5 does make plus 3, doesn't it? So minus on the 5, plus on the 2 times 4 to make 8, and then the middle is made 3. That's the right factoring. That's kind of a pain. A lot of people aren't comfortable with that. That's okay. You can do the quad. So let me finish it. So then you would set each one to 0. You'd say, okay, I got to have the first one 0, second one 0, move it over. So 4x is 5, divide by 4. So 5/4, move it over, or -2. 5/4 or -2, D, there it is. Now, let me do the quad for you also, because I know that factoring is hard. Everybody, any questions I can answer in the factoring? It's basically just foiling. I'm just guessing around till the foil works. If you're not familiar with my system, it doesn't matter at all. Whatever system is fine. In the end, all the systems are just, hey, make the foil work. That's what they all are in the end. Just keep tinkering with it till it will foil to become that. Then you've got it factored. That's all factoring is on multiplying, right? Reverse multiplying. So that takes practice, though. But anyway, let me do the other way. 4x squared equals, what was it? 4x squared plus 3x minus 10. So 4x squared plus 3x minus 10 equals 0. Is that what it was? Yeah, and this is still number 8. Yeah, a lot of people prefer the quad. So let me just do that for you. That is easier, because that was a hard factoring one. So remember the quad, negative it's a b there, plus or minus square root of b squared minus 4ac all over 2a. This is a, b, c, so negative b, negative 3, plus or minus the square root of b squared minus 4 times a times c all over 2. We'll get the same two answers. This is a different way. This is instead of factoring, right? Instead of all that painful factoring, which can be tricky, you could just do the quad, which is pretty straight ahead. Negative 3 plus or minus square root of 9. Now careful on your signs when you do the quad. Watch the signs. Right, negative, positive, negative. So that's two negatives. Going to be positive, right? Use your calculator. 4 times 4 is 16. Times 10 is 160 over 8. Negative 3 plus or minus root of 169 over 8. Root of 169, you might know. Calculator will tell you for sure, is 13. So we get to that. What do we do now? Separate them. Minus 3 plus 13 over 8 and minus 3 minus 13 over 8, which is what? 10/8, right? 13 minus 3. Reduce it, 5/4. So there's that first answer we got. How about the other one? Minus 16/8 minus 2. There they are. That's probably easier for most people. Just do the quad instead of all that factoring. Same two answers. Is that good? Questions on that? So that's for x squared equations. Anytime you have x squared, get a 0, and you can just do the quad. There'll certainly be one x squared equation on the exam tomorrow. And x squared, yeah, x to the second power. There will be. And you can just do the quad, put that on your 3x5 card. I say that about everything, but hopefully there's still some room there. Good, no questions? All right, absolute value can be tricky. It really can. It fools a lot of people. So you have to remember the difference between absolute value greater and less. So absolute value 5x plus 2. 2? Yeah, 2.
Yeah.
That's a
Greater than 3.
yeah, the absolute value bar almost looks like a 1 there, but yeah, they don't make them very big. Anyway, 5x plus 2 greater than 3, yeah. So for the greater ones, guys, the greater always ends up having the 2 parentheses, and the less, which will be the next one, see that's less equal, whatever, we'll just have 1 parenthesis. Do you know that? Just that much can eliminate a lot of possibilities. Absolute value greater, I'll show all the details, but first, right off the bat, the absolute value greater answers always have a greater number of parentheses. And the absolute value less always have a less number of parentheses, just one set. So looking up here at number 9, which is a greater problem, greater, so no way, no way. It's not C and D. I don't even need to think about it. See how quick that is? It's either A, B, or E. Could be none of the above. Just right off the bat. And then on number 10, no way for B and D, because this is a less. Number 10 is absolute value. I'm talking absolute value. Absolute value greater has 2 sets. Absolute value less has 1 set of parentheses. So I've already eliminated a bunch of possibilities on both those questions by that. Yeah?
So greater than is when it's pointing towards the part of it that has the x?
Yeah. So yeah, good question. So here's the absolute value, and it's the wide mouth. So yeah, so the symbol, basically the way the symbol works, it has a wide side, so whatever's on that side's greater, and whatever's on the narrow side is less. So if you turn it the other way, this would be the less side, and this would be the greater side because it's on the wide side. The wide side's the greater, the wider side. So the absolute value is on the wide side, so he's greater. And the next one, you see the absolute value is on getting the narrow side, so he's less. Yeah. Good. Okay, let's finish it up though. So there's that basic fact. Now let me actually get all the way to the answer. So, okay. So absolute value 5x plus 2 greater than. So what do? Well, you have the removal stage where and that's the most important step, where you remove the absolute values. How do you do that? Well, there's one way you do it for greater and one way you do it for less. Greater, again, is going to have greater amount. It's going to have 2 separate with an or in the middle. So how's it work? You remove the absolute values, and then you switch the sign and switch the sign. Both. Opposite. You switch the symbol and you switch the sign. See, I turned the symbol the other way, and I changed the sign on the 3. Opposite, opposite. Or, and the other way, you keep it the same, same. Same, same. Do you see that? It's opposite, opposite, or same, same. That's what you do for absolute value greater. And that's the most important step. The rest is just normal. Just solve it. Just go, oh, okay, I got. Once you make it through that, you're going to get it, you know? Just subtract 2. So if I was to put something on my 3x5 card for this, I would probably just put just that amount. Doesn't use up too much space. You know how to do it from here, right? That's the crucial step, that you know how to separate it into the 2, opposite, opposite, same, same. You're going to be good. So then 5x, what's this, negative 5, divided by 5. X is less than negative 1. Other side, subtract 2. 5x is greater than 1, divided by 5. X is greater than 1. So how do you do this? What's less than negative 1? Well, that's negative infinity up to negative 1. Greater than 1/5? Well, that's 1/5 to infinity. It's B. Is that good for absolute value greater? So I'm going to move on. You may or may not have got that all copied down. I got to... All right, number 10. Number 10. Absolute value of x plus 2 plus 9 less. This is a less one. So we know, like we already said, it's not going to be b or d. It's going to be less. It's going to be one set of parentheses, huh? Okay, so how do we say, what's the first step on this one? We got to get rid of that 9. Yeah, first get rid of that. Because you got to have the absolute values alone to do the removal thing. We good to there? Now the less removal. So how do we do the less removal? So we're going to pull off the absolute values. So first I got it alone, right? That's testing that. That'll be on the real exam, where you have to first get it alone. The last one already was alone, number 9. But this one you had to first get rid of that 9. Now remove. What happens when you remove? Well, it's not going to be the two separate. It's going to be the compound, triple inequality, where you put the negative 4 here and the positive 4, just regular 4 there. And which way do the symbols go? Both the same. Same. Because we're saying that's in the middle. Right? It's like ordering a soda. Small is smaller than medium. Medium is smaller than large. Right? That's the right way to say middle, isn't it? Small is smaller than medium. Medium is smaller than large. That's what we're saying. Smallest, medium, large. That's what we're saying. It's between the smallest negative 4 and the biggest positive 4. That's what we're saying. So it's the triple statement. See how that's different than the greater, which has the two separate with the or? Opposite, opposite, same, same. But the less has got the triple statement, both the same, both less. All right, and then we solve it. It's all about x. X is saying I want to be alone. Subtract 2, boom. Is that minus 6, 2. So it's between minus 6 and 2. There it is, see. Again, don't worry about the brackets, parentheses. Just grab that answer and move on. I'm not going to try, promise. I'm not going to try to make it like, ooh, minus 6. I put a parenthesis. You didn't see that. No, that'd be dumb. I think that would be cheap. So that won't happen. Minus 6, 2. There it is. We got it. Next question. Good on that? We got 5 minutes. Do you want me to jump in? Is there something you want to see near the end? Want me to just jump there? What do you guys want to see? 13? 13? Yeah, I mean, you tell me your favorite. So 13 is the make the box. Remember, we did that. That's what we just did recently, right? We got to fold the box thing. And so it's all about this right here, the width of volume. They're asking for the volume. If you read all these words, blah, 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 volume of a box. So how do you find the volume of a box? Length times width times height.
Height's always x.
Length times width times height. That's the volume of a box. Put that on your 3x5 card. So what is from here to here, inner edge to inner edge, is going to be all the way 25 minus 2x. Remember how we did that? Right? Because outer to outer, it's saying up here, from outer edge to outer edge is 25. And then we're going to subtract this piece, because those two pieces are going to fold up, aren't they? They're not going to be part of the width after we cut them out and fold up. They're going to become height. So the inner to inner is just 25 minus the 2 x's. Y'all with me? From there to there? Because you 25 outer to outer, back up x, back up x. 25 minus 2x. So that's this right here. The width or length or whatever you want to call it, doesn't matter. And then what's inner edge to inner edge here? It's outer to outer, 13 minus 2x, same kind of thing. So here to here is 13 minus 2x. Good, and then what's the height? That's just x, because that x is what folds up to become height. Okay, so there, length, width, height. So here we go. Volume equals, and it doesn't matter what order you put them in, just boom, boom, boom. Any order. Doesn't matter at all. 25 minus 2x, 13 minus 2x, x. Now, they want me, look at what they want, guys. It even says in the words. Then use your graphing, right here. Then use your graphing calculator to graph the function and find the max. So they want me to type this into my graphing calculator, graph it, and find the max. Therefore, I'm not going to bother to FOIL all this out. Why bother? The calculator can do the dirty work. Just call that y1. Get rid of the v. Say your y1, and then graph it, and find the max. And that'll be your answer. Is it A?
Yeah.
Remember, it's A. If you have trouble with that in the graph calculator, come see me. Be glad to help. Don't have time right now.
If you FOIL it out, though, you could use the biggest number as your range. That's what I would do.
Okay, yeah, if it helps you, but I think it would be fine. You could tell all the answers are around 2, right? So just make your window go like 1 to 3, right? I mean, you know the answers are around 2. Use that to your advantage. Yeah.
Find the maximum of whatever it is.
Whatever you see, you'll see like a U shape or something. I don't know. Find the max. Yeah, that's all you need. I wouldn't even FOIL that out. Just type it in. Make your X window 1 to 3. Boom. So what else do you want to see? 14 or something else? You got like 2 minutes. What's your favorite? We did 14 before. Remember the distance ones? You used the distance formula. We did those last time.
25, maybe?
Yeah. Say it so it's free points for you.
Oh, I get it.
Yeah, so 15 function of if you have y squared or plus or any even power, any even like y squared, y to the 4th, y to the 6th, or plus or minus, not a function. Kind of scribble in here. Or plus or minus, not a function. So any kind of even power on y or a plus or minus anywhere, there's an even power on y, not a function. Just like that. Don't worry about x squared. X squared's fine. But y squared, not a function. Yeah. 25. Yeah, somebody else wants to see that one too. So maybe with our last minute, 25. Let's see. 25. Find the function. What's going to be done? So we take y equals root x, and they go down 8. So that's a minus 8 out there, right? Down 8. Good so far. And reflect about the y-axis. Remember the y? This is the y. If you reflect, that means you go from there to there. It's a sideways flip, isn't it? It's grabbing the y-axis and turning it like a rotisserie. And the things go, it's a sideways flip. So, right? Everybody see that? Sideways flip. That's what a reflect about the y-axis is a sideways flip. What's going to make a sideways flip?
Negative.
Negative right on the x. Like that. There it is. Whatever answer that is. Is it none of the above?
Yep.
Oh, that's tricky. There it is. All right, guys. Tomorrow's part 1. Thursday's part 2. Come see me. I'm upstairs right now. I'd be glad to help.